All right, let's take a deeper dive into sphericity here. Sphericity, which is sometimes referred to as compound symmetry when people want to use a more confusing term. Again, it's the main assumption here, the main aspect of it is that the correlations between each measure are roughly the same. You can see how complicated and detailed this gets when we have a lot of measures. With 4 measures, we're going to have 6 opportunities to form correlations. And again, as I mentioned, it's going to be pretty uncommon to see stuff that's really far apart correlated strongly. That's things that are very, very close to each other, which is one of the real limitations of this test. It rests on assumptions that just can't be met. And we evaluate the assumption using the greenhouse geyser statistic. So these measures were, and one thing we can see here from the correlations, those measures that were far apart, like pre-test and 12-month correlation of about 0.5, comparing that to the correlation between between pre and post, about 0.62. So you can see how we're kind of getting that degrading of correlations over time. Now, evaluating the correlation matrix shows us that, but again, we run into the problem, well, how bad is the problem? We don't know yet. So there are a few tests that people provide for this. The first is Mauchly's test. Mauchly's test is a significance test. If you've got a significant Mauchly, if you're using that, then it would be the case that you have violated the assumption. The problem with this test is that it is not any good. This is very much like the problem with the Levine's test. When you have a small sample, it's insensitive. When you have a large sample, it's very sensitive. You can see here the Mauchly test is not significant. What does that tell us? Well, it tells us that we have no problem. But if we look at the greenhouse geyser epsilon, we can see that it drops below that 0.05 level, indicating we do have a problem. So never use the Mauchly test, although there's plenty of evidence, there's plenty of places throughout the internet where people will be recommending that to you. All right, the Fericity correction, just to show you how these work. All these are doing is giving a multiplier for the degrees of freedom. So if I took if I take my degrees of freedom of 23 and multiply it by the greenhouse geyser epsilon, and then do the same for my test of time, that's going to give me those reduced degrees of freedom, much like we see with the Welch's test. So that's where that's coming from. With Welch's, it's a formula for doing that. Here, we just have this Vericity correction. And again, you can see as we get worse and worse and worse, as we get to 0, we drop down to very little degrees of freedom. As we get down to 1, it's going to be no adjustment whatsoever, or get up to 1. And again, our value is about 0.82. That would land us over here in the use the linear mixed model realm. So we'll talk about how to do that in a few minutes. And again, how do they work? Well, it's just the multiplication. You can see what the different values would be coming from there. And you can see this is how we get that greenhouse geyser probability just based on those new degrees of freedom. You see, I took the greenhouse geyser, and then degrees of freedom 1 is 3 multiplied by greenhouse geyser, degrees of freedom 2, 69 multiplied by the greenhouse geyser. And there you can see the probabilities match up exactly, because this is how we're getting these values. All right, 2-factor within. This is just like between subjects factorial ANOVA, except we've got 2 within subject factors. The only new issue that pops up is that we now have multiple tests of sphericity, potentially one for one each for the factors and for their interaction. And you can be in situations where you actually end up using different adjustments for each one. Instead of doing that, I'd probably say go whichever one is most conservative if you're picking 2 different ones. That's not really a rule. It just makes it's a stylistic choice that I like for consistency. You could do it either way. There's no right or wrong way here. One of the advantages here, we see simple effects get easier. We don't have to mess around with our simple effects. They actually can be conducted using just paired t-tests, which is nice. All right, expanding the previous example, we're going to add a second factor, which is going to split each of the time periods in half. And during those two time periods that get split in half, there's either going to be free condoms available or free condoms not available. So adding those those additional conditions creates 8 measurement points, and it also allows us to establish an interaction between time and presence of free condoms. Restructuring is the same. We just have 2 variables. Here I'm doing a little extra coding to know which of the 2 conditions is going to be pre, which of the 2 conditions, which 2 conditions will be post, and so on. And then restructuring with the gather piece as before. Want to make sure we have an ordered factor. And just to show you what things look like now, we've got ID, risk, and both of our within subject variables, time and condom. In terms of the analysis, we again want to have this contrast option. We always need that whenever we have more than 1 factor. We just add condom as the second within subject factor. And you see we get significance tests on everything, on all 3. Looks like all 3 are statistically significant. We look down to the greenhouse geyser. We have 2 greenhouse geyser values, one for time and one for the interaction. Again, the reason why there's none for condom is it only has 2 levels. The greenhouse geyser values are below 0.85, but definitely close enough to, but definitely above 0.5. So if we were using an adjustment, it would be the Hunfeld adjustment, which is probably going to be the more common adjustment for getting used. Again, though, we have at least 3 people per condition now, 24 people in 8 different conditions. So the recommendation would be to use linear mixed model here. So we had a significant effect for everything. Just like with between subjects designs, we want to take caution when we're interpreting main effects in the presence of an interaction. It looks like we do absolutely have a true main effect for condom. There's clearly an effect there, where where free condoms result in far less in better risk scores. The interaction here. It probably says the program's more effective when it's paired with free condoms, because you see that big jump there. We're going to break this down with 4 paired t-tests. 1, looking at the effect of condoms at pre-test, at post-test, at 6-month, and at 12-month. We've got all of those t-tests here. You can see they just go in order, pre all the way to 6-month. They're all statistically significant. However, one big difference we see here, and this is how I would just be describing it, is the effect size is considerably smaller in the first condition. It is a substantial effect size, but it's a good bit smaller in the pre-test than it is in the other conditions. So that's suggesting that when free condoms are paired with having the program, it makes the program even more effective. And the program really does need that free condom component to be its most effective. Again, people perform better at each level when they're provided with free condoms, so free condoms are definitely important. But when we're paired with this educational program, we see the biggest jump.